Good morning, students. So in our last class, we have done one example from the chapter application of derivatives, topics the maximum and minimum, because already we have completed the exercise 6.5, isn't it? So that's why we have to do some example questions, and the example number I think 32 we have done. So today here we have to do another example. If you see, the example is here given like in this way. The question is given: find all the points of local maxima and local minima of the function f given by fx equals to 2x cube minus 6x square plus 6x plus 5. So here the question is given. So first of all, the question is given here. If we start the solution, so given fx equals to 2x cube 2x cube minus 6x square plus of 6x plus of 5. If we verify this one more time, so fx equals to what? 2x cube minus 6x square plus of 6x plus of 5. This one is the question given here, function fx equal to, and now we have to find out the local maximum values and local minimum values. So that means here we have to apply the second derivative method. With the help of second derivative method, we have to find out the local maxima and local minima values. Is it clear? For that reason, the first of all, what you have to do here, first of all, we have to differentiate the result with respect to x. So therefore here, if we differentiate this one, so f dash of x, so f dash of x equal to what we write here? 2 constant term. If you differentiate it x cube, then here we get 3x square. Ultimately 2 3s are 6, so that's why here 6x square we get. And second time here, if you differentiate this one, 6 is the constant term, x squared means twice x. Ultimately here we get minus of 12x. And then finally the last one is 6 is the constant term, so 6 ddx of x is 1. And finally the ddx of constant term equals to 0. So if we differentiate the result, we get the answer here 6x square minus 12x plus 6. Is it clear? Okay. Now the next step is here, what you have to do, we have to write f dash of x. So f dash of x equals to 0 we have to write. So f dash of x, in place of f dash of x, whatever the result we have to put here. So if you put this one, then here we get 6x square minus of 12x plus of 6 equals to 0 we get here. Is it clear? Okay. Now here, from here what is common? 6 is common, so simply here remain x square minus twice x plus of 1 equals to 0. If we take 6 common, then here remain x square minus twice x plus 1 equals to 0. And now if we factorize this one, then here we get x minus of 1 whole square equals to 0. Is not it? Because a square minus twice ab plus b square. That means we can write here a minus b whole square. So from here easily we can write here either x minus 1 equals to 0 or x minus 1 equals to 0. Ultimately the meaning is same, so that's why here we write x minus 1 equals to 0. And from here we get the value of x is equals to 1. Which one is our critical point? Is not it? So now at this critical point we have to verify whether it is maximum or minimum. Okay. So here we have to solve this one by second derivative method. Only for that reason, what you have to do, first of all, here the differentiation first derivative is this one. So this part we have to differentiate again. Is it clear? To apply the second derivative method. So that's why if you differentiate again differentiating. So if you write here again differentiating, what you have to do, if you differentiate this one, f double dash of x, so f double dash of x equals to here 6, x square means twice x, so that means 12x. So that's why here we write 12x minus of 12 constant term here 12, ddx of x is 1, ddx of 6 constant term 0. So ultimately here we get 12x minus 12. So from here what is common? 12 is common, so that means x minus 1. So f double dash of x equals to, we get here 12 into x minus 1, isn't it? So now we have to verify this critical point at this function, whether it is maximum or minimum. So therefore what you have to do, put. So we have to put here x equals to 1. So if we put x equals to 1 here, so we have to write here f double dash of 1. So f double dash of 1, when you put here, you see 1 minus 1, 0. Ultimately the result is what here? 0. So if we get the result is 0, so we can't say anything here whether it is maximum or minimum, because if second derivative is greater than 0 then minimum, if second derivative is less than 0 then we get maximum, but if we get equals to 0 then we can't say anything here. Is not it? So only for that reason, first of all, what you have to do here, the second derivative is failure. So what we have to do now here, we have to differentiate the second derivative one more time to verify whether it is maximum or minimum. So that's why again differentiating. So now here, if you differentiate this one, again differentiating here. So if you differentiate the second derivative here, so after differentiating this one, we get the third one, third derivative. So in case of third derivative, if you see here, ddx of 12x, simply here we get 12 because ddx of x is 1 and ddx of minus 12 is constant term 0. So ultimately f triple dash of x equal to 12 we get. Now here if you put x equals to 1, so if you put x equals to 1 here, f triple dash of 1 equals to, there is no x, so that's why answer is 12. So that means this one is greater than 0. So we have to stop here. So now we have to verify whether the critical point at x equal to 1, it is maximum or minimum. But in this case, one thing you see here, the derivative results are maximum and minimum when it is only even derivative. That means if the derivative is second, if the derivative is fourth derivative, if the derivative is sixth, then we get the maximum or minimum value. If the derivative finishes at odd derivative like 3, 5, 7, in this case, if we get the value greater than or less than, that means positive or negative. So in this case, our answer is what? The function has neither maximum nor minimum because this function finishes at odd derivative. So only the result we get in case of even derivative. Only for that reason here the answer what you have to write. Finally our conclusion what you have to write, fx, that means the function is this one. Fx has neither maximum nor minimum values. Is it clear? I hope all of you understood. If I repeat one more time here, in case of even derivative we get result, in case of odd derivative our answer is what? Neither maximum nor minimum. So that's why here this result finishes at odd derivative. So that's why our answer is what? Neither maximum nor minimum. Is it clear? Okay, thank you.